Alright, review question number 1, graphing these points. Looking at point A, notice that A has a measurement that's in radians. So just doing a quick conversion on the fly here, pi over 2, that's at 90 degrees. Like I said before, I like to plot the angle first. So rotate yourself 90 degrees and go in that direction 5 units. There we go. There's point A. What we did with A just one more time, we start here, go 1, 2, 3, 4, 5, and rotate into that direction a total of 90 degrees. Okay, time for point B. Negative 5 pi over 6, converting that one on the fly, that should be negative 150 degrees. So if we wanted to rotate negative 151 degrees, picture a point right here at 0, and then we go clockwise 150 degrees, which would land us right there. Now because our R value here was a positive 3, now we can go in that direction 3. 1, 2, 3. End up right there. So there's B. Let's look at the next point. Point C, negative 6, 75 degrees. So once again, let's rotate ourselves 75 degrees. I like to deal with the angle first. 75 puts you right there. Now, because we're at a negative 6, we don't want to go in that direction. We want to go away from it. So what we're going to picture here is picture a line going through 75 and going out through the other end. Now when we have this line here, we want to go in that direction 6 units. So let's grab our point and let's get us there, and let's count ourselves out to 6. So there's 0, count ourselves out to 6. 1, 2, 3, 4, 5, and 6 right there. Okay, let's handle point D. Point D, negative 2, negative 300. So let's first deal with the angle. Let's rotate to negative 300 and then go away from it 2 units. So rotate to negative 300 degrees. It's going to put you eventually up there at 60 degrees. Then we want to go backwards 2 units. So I'll draw a line here going through 60 all the way to the other end out to 240. And then we'll just go backwards 2 to finish this graph. So there's point D. Alright, so question number 2. Now you're going to have to list 4 different pairs of points that will get us to that point right there, M. Quick way of getting this is to first picture a line that cuts through point M and also comes through the other side. Just like that. Now, what we're going to do here first is get the obvious first answer for point M, and that's when we list an answer that has a positive R and a positive theta. To do that, realize that we're just going to go counterclockwise to arrive at point M. So when we rotate counterclockwise to get to point M, we can just read the degree measurement that's right on the graph. Now to pick up another point, just now approach point M going from the other direction, going clockwise. So to get this angle right, realize that we're going clockwise here, and we only rotate 135 degrees clockwise. So to label that, we write it as negative 135. And we're going out 4 units. Now to pick up 2 more points, imagine that there was a point on the other side of M, the same distance away. And now you're going to repeat this whole counterclockwise and clockwise process, only now we need to land at that point there, and when we go to those 2 points in the counterclockwise and clockwise, we'll pick up a case where we have a negative R and a positive theta, as well as a negative R and a negative theta. So we have our negative R with our positive theta, positive 45, and our negative R with our negative theta, negative 315 degrees. We got to rotate all the way around there to get to that spot. And so that's how we attack those problems. Alright, so that brings us to numbers 3 and 4, being able to convert polar coordinates and rectangular coordinates into their counterpart. And so being able to do this this requires a solid understanding of the two conversion formulas that we use. To go from rectangular to polar, we need to use this formula here. So now when we convert here, realize that we are working with an x and a y coordinate here with 5 and -9. So our first move, let's go and collect r, and to do that we need to use Pythagorean theorem. Now we need to get theta, so to get theta we have to use inverse tangent. Now taking a look at this angle that we use with inverse tangent, take a second and check the quadrant to make sure we can keep this angle. If we go back to the original point, 5, -9, that's in the fourth quadrant. The angle that we have here with -60.9 degrees is also a fourth quadrant angle, which makes us very, very happy. Now it's time to write our point, and let's put this in polar form. Okay, so let's take a look at number 4. Now that we have a polar coordinate, let's convert this into rectangular. So to do that we need our rectangular formulas, which is r cosine theta and r sine theta. So let's go after x first, which will lead us to having 4 times the cosine of 135. Using a unit circle, the cosine of 135 is second quadrant, so we're at -√2/2. Multiplying there allows us to cancel a 2 out with a 4 and reduce it to get our final value for x of -2√2. Now let's get y. In order to get y, now we take 4 times the sine of 135. That second quadrant angle leads us to a positive sine of +√2/2. And with that positive √2/2, we can reduce the same way we just did with cosine to get us our y value of +2√2. So our final answer here, putting this in rectangular form, is -2√2, comma 2√2. Even here we can do the quadrant check. 4, 135 is in the second quadrant when we rotate in that direction. And so is our rectangular coordinate of -2√2 and +2√2. Put us right in the second quadrant. So we're good to go here.